everybody, today we'll have a new video and we will be overclocking Mocha builds that I was built for a while, and I promised to you that I will do overclock but never delivered. So today I have somebody who's going to help me. This is Cyclops from OCN. Here you go. So he will help me to work out through the overclocking process, explain how to do it, and hopefully we'll do it pretty fast and get good results. I never overclocked my system before, I only run on stock speeds, and if you remember, I showed you some results from the OCN LAN party, but today we actually will go in for something more serious.
Hey guys, Cyclops here, Daz's guest today. Today we'll be looking at overclocking the Mocha belt, which is standing right here. If you guys haven't seen the specs or how it was built, you should definitely take a look at the previous video, the belt logs and everything. It's a pretty kick-ass little belt. For the main specs though, I'm just going to go over them one more time for the sake of just naming them. We got a i5 4670K running at stock settings for now. We have an EVGA GTX 770 reference card. This is the ACX cooler, doesn't matter since it's water cooled. We have the Corsair Dominator Platinum memory. We have the motherboard is a Z87N Wi-Fi. It's a gigabyte version. Corsair X 750 power supply, plenty of power for this rig. Could be even a bit overkill, 500 watts, decent power, 500 watt would be enough, but this is what we have in hand. We have the water cooling components. Intel 510 250 gig SSD, older generation, but still plenty fast for what we wanted. The 240mm dark side radiator, 64mm thick, with 2150 RPM gentle typhoon fans. Excellent choice, I might add. On pull, sorry. We have a DazMode Maple Leaf Special Edition water block. Pretty good, pretty cheap, performs really well. We have, I forgot what the memory cooler is like, but that's not really important since it doesn't have much heat to the system. We have what was the
2D5.
2D5, the DDC. Two DDC pumps. Yeah, we got the amazing Iron Man, or as we like to call it, the Bioshock dual reservoir, and we have a what was it, the Heat Killer? Yeah, Heat Killer GTX 770. Reference design GPU water block. So without further ado, let me go talk through the overclocking steps and see what we can do with this system. Okay, so I got Daz here next to me. I'm going to go over a couple of basics. First things first, when you're overclocking, always take a look at your temperatures. You want to make sure that it's alright at all times. Sometimes see people what they usually don't do when they do leak testing and trying to get rid of the bubbles. When you're overclocking and stress testing, the heat actually causes more bubbles to move around the loop. So that might change temperatures, it might create air bubbles, so always keep in mind that. I learned that the hard way, almost killed the motherboard once, ages ago. But anyway, so the software suite that I'm going to be using, kind of old school. We got Core Temp 1.6 here. It's really old software, not that great, but I've been using it for over 6 years. It always works for me. We got the task manager here open just to show the load on each of the cores on the processor. Remember, this is an i5, 4 cores, 4 threads, so there it is. And we got the latest version of CPU-Z, or CPU-Z, this Canadian site, 6.8.2. As you can see, the CPU right now is running at 800 megahertz, but that's because it's on a low power saving mode. They always do that when there's not much load going on. They kick down really low to keep the voltage low, temperatures low, power consumption low, everything low. So what we're going to do is a simple test. Just going to measure the stock performance because we need to know where we're going with the overclock, see how much performance we can get out of it. So for instance, we're going to launch Cinebench. Cinebench 11.5 is my favorite software. I've had this since I was a fetus and still works great. It measures the CPU performance in single-threaded and multi-threaded mode. So no matter what you have, it just basically runs it at 100% and gives you a really nice juicy number at the end, so you know. We're just going to run the CPU real quick, and I guess we'll do a real quick edit and come back when the benchmark is finished.
So is it overclock or no?
No, it's stuck. Okay, so it's done. 6.15, that's kind of representative for the processor. Now remember, I had a couple of programs run in the background. That can diminish the end results a little bit, but that's okay. We're going to do the same exact thing after we're overclocked. So 6.15, we're going to remember that number, and that's basically a calculation of how long it took to render this offline image, or to do an offline rendering. So we're gonna close that and take a look at the temperatures. It really didn't go all that high. 48 degrees was the maximum temperature on the hottest core, which is okay. Another thing I should mention, since this is a Haswell processor, I'm sure you guys know or have heard of it, that there's some problem with the thermal interface material they use between the die and the IHS. Ideally, I'd like to delete these processors by using a vise and a hammer. This kind of method is pretty popular with enthusiasts. It's not the safest thing to do, but you know, if you want to shave 10, 20, maybe even 30 degrees off your processor temperature, that's a good way to go, especially when you're pushing high voltages. So now this part is done. We're going to go through the BIOS and see what settings we need to change in order to make a quick and simple overclock.
Also like to mention, for the reference point, we have 24 degrees in the room temperature, so we can figure out what's the delta from room temperature to what we're getting as a cooling performance.
Exactly. So yeah, 48 was the maximum CPU temperature, so 48 minus 24, it's 24 degrees delta, which is typical on a water-cooled system. Pretty good for stock operations. And one thing I forgot to mention, the CPU load. We're just going to load it real quick with Cinebench one more time just to see the VID, or the stock voltage the CPU runs at. It's at 1.122 volts. Let's call it 1.12 volts. That's the stock voltage that the CPU runs at when everything's left at stock. So we're going to take that a little bit higher, but again, once again, I'll walk you through it when we get to the BIOS.
It's also important that water cooling system is a bare minimum. So we have two hot components, CPU and GPU, and there's one dual rod on the system, right? So we going absolutely minimum recommended for this kind of setup. So we wouldn't get crazy results as we would potentially have a little bit more cooling power.
That's right.
Although you have a slightly different opinion on that subject, but
well, thanks for distracting me. I just missed pressing delete to get into BIOS. But the thing is, to cool the system properly, 240 is enough, especially when we consider the 2150 RPM fans. They're more than enough to cool it. But again, if you had like a bigger radiator, like a 360 or 480, you could go with much lower RPM fans. So there's the balance there. But for this form factor, I think the combination is great, especially that we have fan control. We can dial the fans down nice and quiet when we don't need it. When it's under load, we can, you know, rendering videos of playing some intensive games, we can turn off a little bit more to compensate for that. So it's very flexible. Anyway, so we're in the BIOS now, and this is a typical Gigabyte BIOS. Now I should mention that I switched to classic mode. The Gigabyte BIOS usually have two modes. One is the UEFI modern mode, which I don't really like, kind of old school, so I go with the classic mode. I switched to that. The main screens you see, the MIT system, BIOS features, peripherals, power management, save and exit. So the bulk of the overclocking is going to be in the MIT sections. What you need to keep your eyes on, overclocking is, well, Intel over the years have simplified it really well. Like ever since Sandy Bridge, all you really need to change is the core voltage and the multiplier. That's all you need to do on an unlocked K-SKU processor to, you know, begin overclocking. But it's also important to know that what the safe limits are, how much voltage you can use. It varies from case to case, but I found that with the Haswell processor, like on a normal condition, if you haven't delit it, anything over 1.3 volts spike up the temperatures massively high. 1.3 is perfectly safe as long as you can keep it cool. One thing people don't know or are misinformed about is the voltage kills a chip much faster than temperatures. You've seen overclockers, you know, professional overclockers and benchers that do liquid cooling, liquid nitrogen, not liquid cooling, liquid nitrogen cooling or liquid helium cooling. They're running the processor temperatures minus 100 and minus 150 degrees, even lower in some cases, but they still manage to kill the processors within a few minutes, if not a few hours, if not minutes, with like voltages as high as 1.9 and 2 volts. So the voltages kill. Temperatures play a role, but much smaller than you think. So always keep the temperatures in check. Even if you have really good temperatures, it's always a good idea to keep an eye on the voltages. So for Haswell, without delitting, 1.3 volts is about as much as I'm willing to go. So we're going to set it at that. Again, another thing I should mention, all processors are different. Even if they're the same model, there's a thing called silicon lottery. So you can't expect the processor that I have to be the same as yours. Yours might be slightly better, slightly worse, a lot better, a lot worse. It's just luck of the draw. There are billions of transistors in these chips, and you can't expect all of them to behave the same way as another exact same chip. So while my processor be able to do 4.4 gigahertz, which is what I've tested at 1.3 volts, yours might be able to do 4.8. It might not even be able to do 4.2. So that variance is always there, and it's important. With Haswell especially, the variance has gone through the roof. They have pulled back on it a little bit with Devil's Canyon. The variance is a bit less, but generally speaking, there's always that. So it's important to use the voltages and the multiplier and find out your own limit instead of just copying my settings. It might work, it might not work, you might need less voltages, it might not be stable, so it's always good to test your, I'm going to show you how to test it and figure out how to find stability. So let's go to CPU core voltage controls. Now there are a couple of different ones here. First one is the CPU VRAM load line calibration. I just call it load line calibration. See, that's a tongue twister. Load line calibration, or LLC. Back in the day, in Sandy and Ivy Bridge days, and even before that, the actual load line calibration was important to stabilize the voltage under load, but in the Haswell and the Devil's Canyon, it's not as important. So you don't really need to change that unless you're pushing like crazy overclocks, like really high voltages. You don't really need to push that. Just for reference, we're just going to set this in standard mode, which is a little bit higher, stabilize the voltage for the V-ring, which is also known as the Unco. So V-ring external voltage. That voltage is, again, used to be absent from Haswell, from Ivy Bridge and Sandy Bridge. It's a new one. It's kind of a support voltage for the actual ring bus for the processor. So 1.8 is the typical one. I found it if I increase it to 1.9 or 1.95, it gives me a little bit more stability. Maybe I'll be able to get another extra 100 megahertz out of it. So it's worth checking out too. If your overclock's not stable, just bump that voltage up a little bit, but not too much. The main one, the main thing, CPU V-core. That's your main voltage. Now, there is debate about how much is safe, how much is not. In my own testing, I've done about half a dozen Haswell CPU i7s and i5s, and one of them I pushed around 1.42 volts. The CPU degraded in a matter of 3 months. So the clocks that I was getting at 4.8 gigahertz wasn't stable. 3 months later, it kept getting blue screens. So that shows that the voltage, that this processor has degraded. So for recommendation, if you've deleted it, try to limit it to 1.35, 1.38 volts. That's like the maximum I would go for. Excuse me, 24/7 operations. Since this isn't deleted, and temperatures I've seen actually spike quite high. We're just going to dial in 1.3 volts. There are different voltage modes. This is more of a basic motherboard, so it doesn't support those. But right now, what it is, it's manual voltage control. So I key in a exact voltage that I want the processor to run at, even if it's idle or under load. It's kind of a brute force of doing it. What I usually like to do, more motherboards with the better features, they have offset and adaptive voltage mode. So those are much more clever. So let's say the offset mode, you add plus 0.1 millivolts. So what it does is under load, it adds that much more voltage to the processor to be stable, and drops the voltages way back when it's not under load. So it's much better for power efficiency as well. But since this is a normal motherboard, and I haven't bothered, since we don't have intern here right now, I haven't bothered updating to the latest BIOS. I'm just using manual mode. It's much simpler. So we just dialed 1.3 volts there. Graphics voltages for integrated graphics, we're not going to touch that since we have a dedicated processor. CPU ring voltage, 1.05. Now, this is important when you're, again, I have to refer to has the Ivy Bridge and Sandy Bridge. We didn't used to have that voltage before. This is a new one. With the Haswell, they introduced something called the ring frequency. It's kind of like the encore of the old i7 950 days. What it does, it doesn't really contribute that much to the performance, but it's still a secondary clock. AMD guys know it as North Bridge frequency, so it's kind of like that. It doesn't contribute a whole lot to performance, but it's still there. The other thing it does, it can stabilize high memory clocks when you're pushing high CPU clocks as well, because what Haswell, the memory control is a little bit on the weak side. You can't always maintain high CPU, like let's say we're running a processor at 4.8 gigahertz. Some processor might be struggle to run like 2400 megahertz memory, so you might have to dial it down to 2200 megahertz or increase the ring voltage. So that helps a little bit there. So just you know, I'm not really gonna go over memory overclocking. It's a bit more time consuming, and I don't want to complicate the video as much as it is. But let's just dial in at 1.15 volts. It's probably a bit too much for what we're going for, 4.4 gigahertz, but it's okay. Just keep an eye on it. System agent voltage is basically your north bridge. It controls the secondary memory voltages that supports the memory controller for it to be stable. You're pushing high memory clocks, you might want to touch that. We're not going to touch the memory, so we're just going to keep it as is. This one's in offset, so for example, you want to run higher memory speeds and you think your memory is not stable. Let's say we add 100 millivolts or 0.1 volts. We won't really need it, so we'll just leave it at, if it lets me, auto. Those are your main voltages for the CPU. And how do we go back? Escape. Yeah, chipset voltage control, won't really need that. This is for your SATA and your USB voltages, your main voltages, never touch those. DRAM voltage, again, we're not going to touch the memory at all, so we don't really do that. So after we set the voltages, we think that, you know, it's kind of safe, it's okay to go ahead. We go to frequency settings. Performance boost is kind of like an AI auto overclocking. We're not really going to use that. CPU base clock, you don't really want to touch that either. I mean, you can set it to manual and manually set it. The base is always 100 megahertz. It's not really worth it to go for higher. Back in the day with locked multiplier processors, it was worth it to touch that, but not anymore. I mean, if you want to get a variable memory clock, that can help, but I don't really like messing with that. So let's just say stick with auto. Processor graphics clock, again, we don't need that. CPU upgrade, again, another form of auto overclock, we're not going to need that. This is the main deal. So CPU clock ratio, right now, the CPU specs is 3.4 gigahertz base clock, 3.8 gigahertz turbo. Depending on the motherboard you get, the BIOS setup, under load, the CPU might run at 3.8, maybe a little bit lower. I found that with this motherboard that under load then runs at 3.6 gigahertz, so I'm not utilizing the turbo to the max, but that doesn't matter when you're overclocking. So I'm just going to set it to manually 4.4 gigahertz. I've tested this before, by the way, I know it's stable, but usually what you want to do is start at a lower value, like 40 multipliers to 4 gigahertz, then go to 4.1 or 4.2, test the stability for half an hour, see if it's stable and keep pushing. Ultimately what I do is do a 24-hour stress test at the end of the overclocking session just to make sure that it's 100% stable and it's not going to fail me. But just to get the hang of it, you know, 30-minute, 1 hour stress testing, something like Prime 95, which I'm going to be using soon. That's very suitable. So 44, we set that there. Extreme memory profile, that sets your XMP. That sets your memory frequency to what the Intel spec is for the chipset and for the memory. So this memory, I'm not sure what it is, but I'm not going to touch it. But you can. It's a very easy way of setting your memory speed. Because one thing you need to do, the Haswell, you need to know is that the Haswell stock frequency when you any memory, like even if you have 3000 megahertz memory, it's going to run at 1600 out of the box. It's important to go down the BIOS and enable XMP for it to run at the correct speed. But again, we're not touching that, so we don't need that, but keep that in mind. Other than that, we're pretty much set. Miscellaneous settings, not important. We basically just dial 4.4 gigahertz, so we're going to save and exit. And after we get into Windows, so sometimes it depends on the motherboard, the whole system shuts down to introduce the new clocks. This hasn't done it yet, but that's what usually happens. So we're not going to go into Windows. Not going to go over stability testing yet, but we're going to go over the performance improvement that we just made out of the stock 3.4 or 3.6 with turbo all the way to 4.4. So same situation. We're going to run core temp, excuse me, CPU Z, which somehow lost its icon, and Cinebench. So we're just going to run it one more time, and well, we're going to fast forward this part, guys.
This one. Nice. The Iron Man. I was thinking more about Bioshock, but when you said it,
it's like the heart. Okay, guys, so we're back, and with that little quick overclock, we're now running at 7.42. The original score I think was 6.15. So we got I don't know what's the percentage. It's like about 10 to 15% of performance improvement just by a couple of settings through BIOS. Yes, the power consumption is a little bit higher, the voltage is a little bit higher, sort of temperatures, but I think it's worth it. If you don't care about those things or if you have them under control, there's your performance marker. One thing to know, the second time you run Cinebench, usually you get higher scores, but you know, just to keep the time at a reasonable scale, we're just gonna do it once. So we're gonna save, and it's probably asking us to rewrite, so no. So the temperatures, the hottest score got to 64 degrees. The room temperature, I think it's still 24 degrees, right?
Could be.
Let's see.
Oh, I think my battery died.
The battery died? Yeah, I haven't noticed any time. Let's say 24, it's around the same ballpark. So 64, we're looking at a delta of 40 degrees, so 20 degrees, was it 40? Was it 46? No, was it 48? So 24 to 40, yeah, so 60 degrees higher temperatures. Now it's important to keep in mind that the more you run a CPU under load, the hotter the loop gets over time. So the heat builds up and eventually gets to a little bit higher temperatures. But you know, I have faith in DazMode's build and the radiator and the fan choice, so no problems there. Now we consider this overclock stable because I've tested it before, but what if you don't know if it's stable? So there are a variety of tools you can use to stress test the processor. My old way of doing it is use Prime 95. Some people might say, oh, that's a crap software. Yeah, it's old, doesn't work. But just recently, about a month ago, they came up with a new version, which is Hazel and Devil's Canyon compatible. The old version used to give too much voltage and just spike up the voltages and temperatures too high, but the new version, the 28.5, is perfect for the job. There are other programs out there like Everest, ADA64, OCCT. They kind of work all the same way. They're a little bit different, but Prime 95 is just what I've been using for years, and it never let me down. So, yeah, let's go. So when you first run the Prime 95, you got a couple of options. Small FFTs, in place, large blend. So what are you looking at is small, large, and random. So what I usually like to do is run large for about 30 minutes to an hour. If it doesn't crash, means it's about 90% stable. Small FFTs puts a lot more stress on the cache inside the CPU, so usually it's about 10 degrees hotter. Now I've already looked at the temperatures, they get pretty high, like up to 97 degrees, but that's because it's a synthetic test. Real world temperatures would never get that high. Let's say you're rendering a video, playing a game, it would never get that high. This is like a kind of like a double life insurance, if you will, of you know, testing it to see if it's stable. Now there are some cases that the program might fail or crash, but you still be totally fine in real world, because again, this puts way too much load on the processor, and sometimes it's just you know, it's not that good.
Do you know, let's say if it runs 97 now,
yeah,
and in the real world, even if you're gaming or rendering, like, do you have any guess what it could be? Like, are we talking about
during
80-ish?
Yeah, during rendering, probably about 75 to 85. 85 if it's like a really high rendering load that's gone for like an hour, something like that. But for gaming, this is, again, we're talking like pegging the processor 100% all the time with extra voltage. So something like that would never happen in real life unless you're rendering a video. Even then, the load would be lower. Playing a game, you need a really powerful graphic card to bottleneck the processor. So bottlenecking is just basically when another part, the CPU and GPU work in tandem. If one is not up to the task, the other one can get performance hit. In this case, these two are a perfect match. We have more than enough CPU power for the GPU, and GPU can happily use all the CPU power it can use. So that's not the case. But if there is a bottleneck, the CPU loads all the way to maximum, right? So it would never happen in any game scenario, unless it's really stupid, bad-written game, which I don't think there are that many out there anyway. So in game temperatures, 60 to 70 degrees, that's what I would see. That's what I've seen in my experience. So yes, these temperatures get a little bit higher and uncomfortable. Again, if you're uncomfortable with those temperatures, the other thing you can do is not stress test and just do your normal work, play your game, you know, render your video, do whatever you want, watch porn, and
not very intensive.
No, but yeah, you can do that, but you know, the system might crash, you might lose your work. That's why I recommend stress testing. It puts an unrealistic load on it, but at the end, it helps a little bit. So there are two schools of thought of doing it. There are other ways you can do it, like even rendering a video. Like let's say you're using Handbrake, Sony Vegas, something like that can use all the processing power of the CPU. You can run that, let's say, like a stupid high bitrate and high resolution video. Let it like render for 24 hours. If it doesn't crash, 99% chance that it's perfectly stable. Again, Prime 95, a really synthetic benchmark. I can't stress that enough. It doesn't represent real world temperatures, but right now we see the temperature 71. I have seen it spike all the way just before 100 degrees, so you know, take it for what it's worth. Another thing I forgot to mention in the BIOS, which I think we should go back. I've tested this, so it's stable. We know 4.4 gigahertz. Just one thing, all BIOSes are different. Like Asus motherboards, Gigabyte MSI, EVGA, they're all different, but the fundamentals the same. Like the V core might be called, you know, core voltage or something like that, just very similar. The V ring could be called Unco. They just play around with the names, but you know, you get the idea after you've played with them a little bit. For example, let's go back to the core voltages. Like the V ring for the capacitor or the VRMs inside on the chip that Haswell decided to do. That's always 1.8 on any motherboard on default. So you know, that like what that voltage does. V core is around 1.1, 1.15 on every board, so you know what it does. Ring voltage is always 1.05, I think, for all cases that I've seen. So even if they're called differently, just by looking at the number, you know which one it is. There are a couple other hints and tricks about this. For example, so advanced CPU core features. You can change other stuff such as on-core ratio, which is again doesn't contribute a whole lot to the performance. You can try like 4 gigahertz, it's probably going to be perfectly stable. Even like 4.2 or 4.3 should be fine, but higher than that you're going to increase the ring voltage, which is not necessary because the performance gains are negligible. The other thing you should keep an eye on is sometimes when the processor cannot supply enough, the power supply can't supply enough, or the motherboard can't supply enough power to the processor, you might see throttling. So you know, you saw it perfectly stable at 4.4 gigahertz. It might start to drop to like 4.3, 3.9. That can cause the cause of that can be two reasons. Mainly, one is the thermal throttling, which is, you know, you can observe it by looking at the temperatures. If it gets to 100 degrees, it's going to cut down the voltage, cut down the frequency to come back to the Intel specified limit. The other one could be the power delivery. So most motherboards have a pretty intricate way of dealing with that, but sometimes you have to set it manually. They're a pain in the ass sometimes. We got the turbo power limit and core current limit. So these are the amount of wattage, estimated amount of wattage that the motherboard can supply to the CPU. Ideally, when you're overclocking, you're using low voltage, you might want to increase those values a little bit to allow more voltage to be given to the CPU so it doesn't throttle. So this is at 95, 84. You'll be fine if you set it to 150, 200 watts. Again, it's not really dangerous because as long as CPU doesn't ask for it, it won't be supplied that much and it will never go over that value, and it's perfectly safe, so you don't have to worry about it. And I think that's about as much as it can teach you in a short, I don't know how long it's been, 30 minutes probably?
Yeah.
But yeah, that's the basics of CPU overclocking and Haswell based processor and Gigabyte motherboard.
So basically what we moved from 2.
Yeah.
So we have a 3.2.
Well, it was 3.4 in stock, but the motherboard was running natively at 3.6. So 3.6 to 4.4. So the Cinebench score went up from 6.15 to 7.45, right?
Yeah.
So that's 10 to 15% performance for like a 15-20 minutes of fiddling.
Yeah, and it doesn't seem we have any issues with
no, it's not
system not capable to handle it.
The system is more than capable. Like if you have a kilowatt meter here, we could show it like even under load with even Prime 95, it probably wouldn't even use more than 200 watts. Normal gaming scenarios, 120 to 150, video rendering 150 to 170. So, you know, power supply is more than enough for us. 750 watt is overkill a little bit, but it's more than enough. And as long as you got quality power supply and a decent motherboard like we have here, you're fine.
I also like to mention that you see on the web and in different forums that a lot of people do totally overkill water cooling builds just for fun of it, right? But I noticed that a lot of people who just watching it thinking that it's kind of mandatory requirement that you need to have, I don't know, 4 quads and all this ridiculous stuff. So I'd like to remind you, so we have a very small case, maybe not even capable to carry too much. So we have a just dual rad, we're overclock CPU, still going with acceptable temperatures, and we have 2 components in the system. We have a GPU and CPU, right?
And so the RAM too.
Well, RAM kind of water cooled as well in my case, but usually it has a negligible performance impact. So we have 2 hot components, dual rad, 14 fans, and it perfectly works fine.
And I should also mention, this is a 22 nanometer processor. These are super power efficient. On idle, the whole system, GPU included, we're looking at 50 to 60 watt of just idle power consumption. And under load, again, it's not like the old 775 or 1366 processors. These things literally sip power. You don't have to overkill the radiator. The 240 is perfectly enough for stock operation under any load. For overclock, you might have to dial the fan up a little bit, but the GTs, I also test fans, and the GTs is one of the best fans out there in terms of noise to airflow performance and static pressure. So component selection is important. Also use your brain.
All right, I guess that does it. We will also look for maybe further tweaking, but this will be a separate video for that. Thank you for watching. See you soon, guys.